Hello, and thank you for joining us for this Autodesk's latest webinar with Car Design News. My name is Nick Holt. I'm editor of Automotive Manufacturing Solutions, and I'm standing in today as all our Car Design News editorial staff are away running a major event alongside the Paris Motor Show. As you know, this webinar will focus on concept modeling with Maya. Over the next half an hour or so, we'll be joined by Autodesk's Martin Emila as he showcases the latest Polygon Modeling techniques. Martin brings a breadth of experience in conceptual design and visualization. His work on the industrial design process covers the complete flow from first sketch to final product, with expertise in creation of conceptual models and realistic visualization using SketchBook Designer, Autodesk Alias, Showcase, 3D Studio Max, or Maya software. Martin joined Autodesk in 2008 as a solution engineer in his design, lifecycle and simulation group, supporting various companies and Autodesk partners across Europe. Now, before we start, I'd like to invite you, all of those attending this webinar, to draw up some questions as you listen to this topic, which Martin will then be pleased to answer in the question and answer session, which will follow immediately after his presentation. You can ask these questions by typing them into the box at the bottom right-hand side of your screen. If you experience any technical issues during the session, please type a message detailing the problem into the same box at the bottom of the screen, and our team will do their very best to resolve them. We hope you find this webinar stimulating and informative. Now it's time to hand over to you, Martin, so that we can begin his presentation. Thank you, Martin.
Thank you, Nick, for the introduction. So, welcome everybody. As I see the registration list today, there are a lot of people outside interested about concept modeling with Maya, so I try to do my best to make this really exciting and informative in the next 30-40 minutes. So we'll see how fast we are. So as each of my presentation, I would like to start with a brief agenda, what's expecting us in the next half an hour. I start with the goals, what's my goals during presenting the process about the concept modeling. I will talk briefly about the Autodesk Maya as a product and show you a live demo how the Maya is used in the concept design process. That's the main part of my presentation, but the bullet number 4 is for me very important as well. It will be more about how the results generated by Maya are, how you can integrate them later in the process and get the benefit of this. At the end, we planned, as Nick already mentioned, a question and answers round. So if you have some questions, be prepared. At the end, we try to answer every of them. So go to the next slides. About my goals. I'm sure that a lot of people know about the concept modeling, but there are different approach how to use the polygons, because that's the main focus of this presentation, how to use the polygons into the conceptual modeling workflow. So that's my first goal, make it more understandable for you, explain a little bit more about the specific tools that are used during this process, and present you how you can use these tools to build up the geometry and explore and modify it afterwards. At the end, I talk more about reusage of data later in the process, and I prepared some example how to demonstrate it, mostly live, and hope you like it. What is Autodesk Maya? Maya is software was long on the market, so it's very well known. It's very frequently used in a movie industry. If you see, every blockbuster is at least a part of the Maya technology behind, and it will be used for generating special effects, animation, rendering the movies or images, perform many other tasks, but that's not this what we are focusing on today. I bring it in a color and in a bold capitals on the screen, talking only about the modeling. So don't be afraid about the complexity. We touch only a small part of the Maya, and it makes this more transparent, more easy to understand, easy to learn, and easy to use later. Maya software is known. Now a few words about the polygon modeling. Polygon modeling is a technique. It was used in the past really frequently, for example, in game design to generate the 3D geometries. low poly geometries to keep the complexity of the objects as low as possible, and is more and more used in a product design as well, due to the higher flexibility and very high speed in terms of creating and modifying the geometry. If I present a principle how it looks, for example, for automotive design, I split my timeline into 4 different segments. Starting with a fast concept based mostly on sketches or simply 3D models, go to the concept surfacing after design fix on the class A surfacing level, and then afterward to engineering. If I try to demonstrate the progress we can achieve with the standard used methods, for example with surface modeling, you can see especially on the beginning in this ramp-up phase you have really slow progress in terms of time runs. So it's something we need to speed up, do different requirements, do a lot of new models preparing for market and so on. Just for illustration, if I try to approach this with a solids, that's no chance to get some valuable progress in a first concept phase. Is not so method it's suitable with this task. With using modeling with the polygons, you are able to achieve the fast progress in a very short time, and you are able to present design, how it's should work, how designer imagine it, or you can present a lot of different variants of specific design. So it's give you a good basement for the later decision in which direction you should move. So that's the mainly the highest positive or highest benefit to using of a polygon concept modeling in this phase. There are a lot of different methods how to integrate the polygons into the process, especially for visualization. It's another domain of where Maya is very strong, especially in automotive industry, but they need a little bit different approach. They are based more on the detail modeling. What I want to present you in the next minutes, it's approach more on main shape, on evaluating the shape, adjusting the shape, and get the best solution from this creative phase. So next question is why especially Maya? What's so special on the software? There are a lot of different packages outside on the market. They deliver the polygon modeling tools as well. So why is Maya so unique? So there are some points I summarized together, but just to be short, Maya is here, Maya is available, Maya is proven. So it's already deliver acceptable results, quality results. You can use it immediately. It don't need next development. It's simply here. Using this polygon modeling method, excuse me, enable you to be really flexible. To use the standard approach with the NURB surfaces to bring some challenges in design finding process. So are not so flexible if you need to move the character line on a side panel, for example, few millimeters down. With the NURB surfaces, you need to open the geometry, retrim it again, so it takes significantly more time to perform this change. With a polygon model, you are really flexible. You don't need to thinking a lot about surface connection, surface degrees, whatever. You act directly on the geometry with a immediate visual feedback. Maya provide very flexible, very complex interface, but it's easy to customize it, it's easy to simplify it on a user level. So this is something what especially beginners very appreciate. They are able, after a few days training, to model, to deliver some results. And I'm talking by my personal experience. We provide trainings for different design offices, design guys, and guys that are not so familiar with the 3D modeling methods. They are using only Photoshop or pencil and paper. They are able, after 3 days, to model the first polygon car using the Maya. So that's for me great benefit, this flat learning curve. Next point is where Maya offer a lot of capabilities is data exchange. Maya is a part of the design products within Autodesk portfolio use the Direct Connect translator integrated inside. Direct Connect is something what Alias users probably known very well. It's a high-end translator enabled to exchange the data with a different application, with the different formats. I'll show you later a little bit more about it. And the next and last point, why Maya, if you are a user of the Alias Automotive 2013, or if you are under subscription with Autodesk, with this last release you receive the Maya automatically in a package. So you don't need to buy the new license, you don't need to invest, you already have this package in-house, you can start to use it immediately, so you don't need to wait at the end. Now I'm coming closer to a live part of the demo. That's my scenario, how I want to present. I try to define some milestones so it's more transparent for you. I'm starting with some reference data I use for a modeling, show you how to organize your scene. Then I start creating the main shape just to define my, my intention. Then complete this shape and add some other geometry on this. Add and refine some details, and at the end I show you how you can explore and adjust this form, this shape in a real time without perform some complicated workflows. So there is something where we want to go. That's my final model. That's only a screenshot, but now I turn into the Maya and we'll see what's happened. I have some chance to check the performance, so I hope it works fine for you. It's not 15 frames per second, but it works well. So that's my goal. That's what I want to achieve and what I want to model. And now I start you how I came to this result. Open the new file. So now you can see it. It looks like an empty scene, but I already have some geometry there. And as you can see, the geometry or all entities or objects are organized in some kind of layer structure. You can see it on the right side of the button. I start with a reference image. So it's first type of geometry or reference I use for modeling. It's quite simple, but no fear, I can change it. But maybe at the beginning some few words to interface. It looks like there are a lot of icons, a lot of tools, but as you can maybe see here at the top, I have one row with different icons. They are all the tools I used for this demo, and that's more or less all tools I use for polygon modeling as well. So at the end, you can really simplify your interface on a very small bunch of icons or comments you're using for performing modeling. Another important point is Maya use so-called marking menu. Marking menu is something what's really famous or known for Alias users. For example, it's some kind of controlling, some kind of way how you control a modeling process or how you control access to the tools, where all the tools you need are concentrated in the place where your mouse is. So you spare a lot of time to running over there on a menu bars to find and activate the right button. You have everything where you really need to have it, and you can customize it on your needs. So at the end you can work with a really empty screen without any disturbing elements, and consequently use the shortcuts in the marking menus. That's a little bit out of scope, so I try to stay on a traditional interface. You can switch between the different views, orthographic or perspective. Now you can see it, and you can switch during the modeling process into these views to achieve the highest precision in terms of selection or moving geometry. But go ahead to the modeling. As I mentioned, I can use a different type of references. This is the picture reference, for example, and I simply use the different image for this because that's not enough what I have now. And yes, I have here some prepared. It's some kind of illustrated sketch, I would say, and it's one possibility what you can do, what you can utilize in the Maya as a reference. So Then second option is you can use a different kind of pictures. You can use a freehand sketch, you can use illustration, photographs, blueprints, whatever, different views, just to get the combination it works best with your intentions. I decide to use one side view and add then additional geometry, NURBS geometry in form of some kind of package representation. There's displayed the position, amount of the passengers, wheelbase is displayed here, some kind of references like windshield line, windows bottom line, and cooler position. So there are some initial starting points I can use as a reference for modeling. And just to add more reality to the model, I put the wheels, imported wheels into the scene just to have some kind of realistic objects to enhance this reality feeling during the modeling. So turn this off, and now we can start with the modeling. First of all, what I need is to create a main shape. So this is the first step. I create the first line or polygons represent at the best my body line on a sketch, on an illustration, and that's the first step to the concept. So create polygon tool, and now I simply click on a scene just to trace the contour of the car. It's not be totally precise. I can adjust it later, but I try to catch some important point or places on a car just to have this basic representation of the body. So that's the first. That's the first step. Then I need to turn this 2D shape into a 3D geometry. I'm using my customized marking menu. There are all the tools I need for modeling, so I don't need to use the menu bar at the top. I can access all the tools here from marking menu, and there's the first step. I create my basic geometry. Now I try to add or try to remove some faces at the beginning to have only the main shape, the outside surface, outside polygon, and now I try to add some lines to be more flexible during the manipulation. So like this. Now I select the polygon line and modify it a little bit to get more smoother shape, more, I would say, curvature, but it's not the exact expression, but something like this, just to have some smoothness on the car. So something like this. I hope you can see it, and it looks well. Next step, I only adjust a little bit the window line, and that can be my first step, my first geometry I've created. Now I mirror it, and that's the step number one, create the main shape. Now one important feature available in Maya, the purpose is during the concept modeling with the polygons to keep the polygon amount so low as possible. So if I create too much polygons, I have a problem to adjust geometry later. So my goal is to have so low polygon level as is enough for describing the shape without losing my intention, my idea behind. And if I need to turn this really rough, really not so smooth defined shape into a nice smooth surface or polygon surface, I use the keys 1, 2, and 3, because key 1 control the rough polygon level, key 3 smooth this polygon level, so create some kind of interpolation between the polygons, and key 2 turn both views in one step on. So I can see the rough lines and I can see the smooth shape behind. So it's really fast method how to verify your design idea and turn between the the different smoothing levels without any delays. That's a big advantage, by my opinion, in Maya, because it's working in a real time. In other software, I know you need to wait till this final polygon smoothness will be calculated and displayed. It may take some time. So here I'm really not disturbed with these breaks. I can control the geometry and smooth the geometry in a real time. So that's the step number one. Now go to the step two. Enhance the geometry a little bit. Just for sure I don't click on a wrong place. I set my reference layers on reference mode. There's again some similarities with the Alias. I can't click by accident on these layers, and that's make me more sure during choosing the different geometry. So as you can see now, I enhance my main shape with some additional objects. I add some wheel arc geometry, some kind of side panel, and combine it together with the main shape. What I need to do now is connect the edges to create the closed shape. There are different tools, different workflows how to do it, but I like to use so-called bridge. So I only select my edges and bridge them together, and it's quite fast. It's some kind of construction history behind something I'm talking about later, but it's for me very, very fast and smooth method how to close the geometry. Bridge. So this one, now I hear some doubled edge, but it's something I can easily manage. And for these two parts I simply use the command called fill hole. It's do nothing else as fill the empty space with a edges edge boundary with a polygon. Here I have some different situations, so I need to create some additional geometry. So I create first one extruded part, let's say like this, bridge together again, and fill hole here. So that's my first step. I can adjust additionally the position of the edges just to have the shape I want to have, I desire. And last step, this face, I would say it's too complex, so I add some split there just to have some simpler geometry. So that's the step two. If I use my smoothing function now, you can see that looks now like a car. It's some kind of potato shape now, but that's the way how the Maya working. If you are a skilled or experienced Alias modeler, you use the I'm sure you use a different approach. You start with a theoretical edge, and then you add some blends and transition on the surfaces. Here you need to turn this workflow vice versa. You start with some kind of smooth, very organic looking shape, and then you add some edges, some character lines to identify, to develop your design, and to modify it afterwards. So step 2 is finished. Now I go to the step 3. That's something similar here, but now I'm talking about the refinements. Now we have seen how I create this base geometry from a simple line or polygon connected with the other parts, and now I need to have some details on it. If I turn the smoothing level, you see that's quite flat without any lines, any breaks, any character. But I try to change it, and I try to add some side edge just to accent more the wheel arc and the bottom line of the car. So just take a look. I select my edges first. Like this, and then very important tool using really frequently in a concept modeling workflow is so-called bevel. So I add some bevel here, and you can see it's happened something. Yeah, if I turn the lowest smoothing level, you see I have instead of one edge, two edges, and there is something I can use later. Maya, as I mentioned, has some kind of construction history. So, for example, I can click here on the right side on the inputs and adjust, for example, the offset. So I can adjust afterwards the distance between the edges, and this has some impact on my resulting geometry. If I use this and working with this tool, you can see it has some impact on a sharpness of the edge. Basic principle is if I need more lines, more density, or more sharp edge in Maya, I need to add the edge line. So it's basic principle and works very reliable in all of the tasks. But at the moment, I'm not completely satisfied with the sharpness. It's a little bit too flat. So I can add, for example, a segment. So I can increase the density on this place with adding the additional segment, and you see now what kind of effect it has. It brings really a sharp, crispy edge and define the side part of the car very straight. That's the first example. Now I create a second one, and that's some kind of shoulder line. I insert the loop. I remove some edges I don't need. Delete it, and same as here, because I need to have the flow over the whole side of car and end it at the end of the trunk. This one is missing. So, and here I need some connections. So, as before, I integrate one additional edge here, and just for sure I check amount of edges if I don't have some duplicated vertices here, so I merge them together. Okay, that's my first step. After this, I select this edge, so you can see it's selected from start to beginning with some additional selection needed, and add some bevel on this edge. Again, this bevel feature, it's very frequently used, and that's no secret behind. It's bring this character to the design. You see here is resulting in some complex geometry or multiple points. So again, I merge these vertices to get some fluent flow on this. So now I try to turn the smoothing mode, and you see there's something there, but it's not so visible. So for this, I simply click and move on these faces just to get some nice sideline on the car. Looks like this. Of course, with this method you can adjust it additionally, so I don't need to be satisfied with this kind of distortion, so I can go there, move some points, and just to smooth, or I can use some advanced techniques to make the surface smoother. That's everything possible in Maya, but I only want to demonstrate this basic approach, how I create my basic design and modify it afterwards. So mirror it, and next step is done. Now I turn in another level. There's more detail now. You see more character lines, and what I want to show now is how you can modify this. So it's no rocket science now. I already show some kind of techniques. At the end, you need only select and modify part of the geometry. You can decide between vertices, edges, or faces, and simply with a moving, rotating, or scaling, then you can achieve the different appearance of your design. That's the one possibility. I can, for example, move my edge to get more definition on the surface or whatever. Here's another good example. I simply pick my vertices, I move them just to create another flow and another character line on a front hood. So, just a second. again, I mirror it, and now I have a car body almost done. What is still missing, it's for example some kind of details like openings, holes, or whatever. And that is a good point, because we don't, or we have the different chances how to bring this kind of geometry or this kind of features on a polygon model. You can model it directly, as I do now with a windshield opening. So I select the faces I don't need. I can detach them or I can delete them. For this, I would say I delete them. So that's my main opening, and then I simply select the edge, extrude it, and bevel afterwards, so like this. And like this. Again, this construction history make possible to adjust it after I perform this task and to find the right proportion of the bevel. If I smooth it, you see I have nice clean defined opening for windshield with a bevel and rounded edges. It looks quite natural. So this is the first way how to do it. There are another ways I mentioned later in the presentation, but that's the approach is working well on a simply and not so complex openings or holes all over the geometry. Now I have the last point covering the modeling task, and it's about the deformation, global deformation, how I can deform my complete shape. For example, here there are some kind of wheelbase I need to reduce, for example, to create the different type of car. So if I turn it here, I already prepared the different wheelbase, and you can see there's a lot of modification. If you are working with traditional NURBS approach, you have a lot of rework in front of you. Here it's quite simple. I only remove some edges I don't need, then go into the side view, select affected vertices in this case and move them. So I don't select everything I need, so one more time. Yes, now it works well. So I simply move it here, and the last thing I need to do is simply move or adjust the roof line just to be sure that's smooth and defined as I need. So that was operation, took some seconds, and at the end you have the same car but in a different variation. The shorter one on a different platform, maybe not 4 doors but only 2 doors, whatever, but it's really flexible and fast. Another way how to modify geometry is to use so-called global deformators. There's something note from Alias as well. It is lattice rig and whatever works similar here in Maya as well. So if I select again a bunch of vertices, I can apply this manipulator on the selected vertices, and at the end I can manipulate very complex geometry with only a few points, these lattice points. So like this. Now I select the lattice points and start to move them. I hope you see it well. So like this. Like this. So it's really well or really very frequently used method to don't touch the base geometry but only operate on a higher level and control this complex underlay with only few points and deformers. So you can do really wild things with, but at the moment I would say we keep it as it is. So that's about the Maya workflow. So I showed you how you can create a base shape, how you can add more geometry or more complexity to the shape, how you can create character lines, some kind of sharp edges, manipulate them, and how you can change the geometry as a complex shape, not only locally. So that's for me some kind of brief introduction into the Maya modeling workflow. There are a lot of other things, of course, but we have only 30 minutes, so that's why I decided to make it more concentrated, more fast. Now I turn back into the PowerPoint, because now I came to another question: how I can reuse the data I generate in Maya in a later process. And basically there are two different ways how to reuse the data. So you can export the files from Maya as a mesh or as a NURBS. If I'm talking about a mesh, I'm not talking about a rough mesh, this basic representation of the shape, but about the high dense mesh. It's some kind of really mesh network with a lot of vertices. They describe the shape very, very precisely. This you can use directly in an Alias. I prepared the example. That's the Alias model. I hope you can see it now. Yeah, that's the Alias model based on the imported NURBS mesh geometry, excuse me. So there's something I did in Maya and save it as an Alias wire, so native file, and open it directly in an Alias. That's a one way. I can use this mesh data, for example, to generate sections. If you are working on a surfacing, on Class R surfacing side, that's the essential or starting point for creating the high quality surfaces. To identify the sections, turn them into the curves, generate primer surfaces, and blend them together, and so on and so on. That's the first approach. You can see the section on the screen now. The second approach is to convert this geometry into the NURBS. You can see the NURBS model here. It's not the perfect layout, nobody tell it, but in this phase it's enough for me to add some specific features on my model, because as I mentioned, in Maya I'm modeling the complex shapes, the whole car, not from a gap to gap. And especially these gaps is something I can easily add on a NURBS model. Simply project the curve, panel gap, and it's done. So that's for me the good combination of the different data models, data types, to utilize the best of both worlds, from polygons and from a NURBS world. How it works in Maya, I show it pretty briefly. I select the geometry, turn it first into the subdivision surfaces, turn it in the second step into the NURBS surfaces. Now I have my NURBS model in the Maya generated within the seconds. So this step, how I turn or how I go from mesh model into the NURBS model, is for me the biggest benefit, or one of the biggest benefits Maya offer to the user, because the NURBS offer you again some other possibilities in terms of next development of the model. So back to the presentation. So here's a short summary how this export or exchange functionality working. As told before, two different ways. High dense mesh is using for milling, for example. You can create a real prototype from this data. You can use it for a fast visualization. I show you in a second how it works. And last but not least, you can use it some kind of luxury scan for a Class R surfacing. It's a basement for a Class R surfacing. If you use the export as a NURBS, you can reuse this data in Alias or in any other NURBS model as a base for adding some features. They are working better in NURBS world, as mentioned, complex openings, gaps, and something like this. But let's go further into the process integration. Now I display some simplified workflow how this may work. So we have the polygon model as a center of complete workflow. You use the sketch input to create this polygon model. You deliver from this polygon model the surface data for additional task, or you can reuse this polygon model directly in a visualization workflow, work in progress visualization to make decision about design, whatever. And at the end, you can reuse the data, the visualization data, again into the sketch software to change your idea, to add some details, to rework your main design team, whatever. That's something I present to you briefly in a minute. So if I go into the next steps, this is about the visualization. I have my Maya model, and Maya offer really lot of features to generate the high-end images, but you need to know a lot about the workflow, about how these tools are working. What I did, I import directly this Maya polygon model into the showcase, and in a showcase I'm able, with a few clicks, add some details, some basic materials, and present this model into the real-like condition. Important is I can predefine my visual setup, and with this way I can create some kind of visual consistent environment and evaluate my models into this environment without any distortion from lighting or from different lighting setup. That's the first possibility, to use some kind of neutral clay shader, just focused on a form, on a shape, and check about my development. Another option is to add some real-looking shaders on a geometry to have more real look on a model, on a concept, and thinking about additional features about the design idea, if it works, if it not works, what we need to change. So I hope it perform better on the screen. I can see it move. So you can see I can easily move, turn the object, and evaluate each aspect of the design from a different point of views. And that's make, for me, this workflow very, very useful, because you don't need to wait on the pictures. You have the real scene. You can turn from any possible point of view and make the decision over your design. That's the next steps, and I'm almost done with the presentation. Okay. Here we are. So that's, for example, one way how you can utilize the data from a showcase. I visualize the basic Maya model, use some simple shaders on a body, on a windshield, greenhouse, and export it as a picture. And after this, I add in SketchBook Designer some kind of sketching tool in our portfolio. I add some additional components to the scene to get more emotion from this. So at the end, it looks like this. As you can see, I add some technical features like gaps, some kind of road surface texture in the background, some kind of highlights, and lighting graphics to get more emotion from this basic polygon model came from Maya. That's the one possible approach. Second is I have one standard visualization without any specific feature or specific components, and I can sketch over this base view just to thinking about my design. So as you can see here, I try to rethink about the position of the air intake, about the shape and position of the front lights, and that's everything is based on this initial Maya polygon model pre-visualized in the showcase. So that's for me nice benefit how you can close this loop. From the first sketch you go to the Maya, you visualize in the showcase, generate the pictures, and sketch over with the sketching tool by your choice. So now it's 40 minutes gone, and I'm at the end now. Just to finalize the presentation, summarize it, I have some points as a conclusion. If you are asking why Maya, it's clear and simple for me. It's here, it's now, it's working, it's proven. You can use it immediately. It's deliver results as you need. For users, it's a short learning curve. You can learn quite fast how to use the tools and generate. Enable fast and flexible modeling way to explore, to find the right shape and evaluate this shape almost in a real time was really important in a fast development process. And the last one, it generates reusable results. Reusable results you can utilize later in the process to get the benefit from this fast conceptual method and integrate it in your existing design environment to be more productive, more fast. So that's all from my side. I hope you liked this presentation. Thank you for your attention, and now I am ready for questions and to take over to Nick and Diana. Thank you.
Thanks very much for that fascinating presentation, Martin. We do have a number of questions from our attendees. The first question is why choose Maya over 3ds Max? What makes Maya better for automotive poly modeling over 3D Max?
Good question, definitely. I would say there are two main points from my point of view. First of all is Maya came from Alias family. Alias is more or less standard in a concept design within the automotive industry, and that's make this collaboration between two products really very effective. So you can directly use the data from Maya and Alias in a wire format. So first point is data exchange. It works better with Maya, by my opinion, by my experiences, as with a Max. It's not impossible with a Max, but I think Maya deliver the smoother results. Second point is, as I show you the workflow with smoothing the polygons, that's something what I can do fast and effective with the Maya. Using the Max mostly for visualization. I tried to model with a similar principle as the Max, but it was still some delay during calculating the hidden mesh in the background, so that's the reason why I prefer Maya in the modeling process. You are more straightforward.
Thank you, Martin. A question perhaps along similar lines here. Maybe this is maybe to focus in something more specifically on this. The question comes: what are the most significant differences between polygon modeling on Maya and the 3ds Max design?
There are no differences. There are simply answer. There are the similar tools, similar workflows. So there's something you can do with all Polygon software that are on the market now. But as mentioned, Maya have some advantages in terms of moving data further into the process.
Thank you. Now, going back to something that was mentioned in the presentation about not worrying too much about triangles versus quads. The question is this something that you're able to clean up later, or is it something not to worry about?
Well, yeah, there are a lot of ways how you can clean and simplify geometry later. For example, you can connect the points together. You can flow the lines into the surface with the help of some workflows. So you really don't need to care too much at the beginning about your polygons, edges, or vertices. That's something really readjustable in the later phases. You need to thinking about a little bit about the layout, where are your prominent lines in a model on the beginning, but there are a lot of chances to adjust it later.
Okay, thank you. Question we have here is regarding the process flow from Maya to Alias Class A. So the question is that this may be good up to for CAD, engineering CAD for automotive. But do you think that from Maya directly to CAD product design is feasible?
That's a good question. I never tried personally, but my opinion is that depend on the layout they came out from Maya, you need to do some rework later in a CAD system on the surfaces. So need to be decided from case to case. I can't give a definitive answer now.
Again, we may have touched on this a little earlier, but the question is why use Maya instead of Max?
Okay, yeah, that I answered before. You have the direct connection to the Alias, and you can generate not only polygons as output, but you can generate the NURBS. And these NURBS for a class R quality is not good enough, but for additional modeling task is very, very useful, because you can add some details on NURBS geometry coming from Maya. It would be difficult to do it directly on the polygons. As example, panel gap. You have the door opening, you need to do some panel gaps. If you model the main shape, then you need to split it, and it brings a lot of challenges and a lot of obstacles. So you turn it into the NURBS, open Alias, project the curve on it, and create a panel gap. That's something what works very well.
Thank you, Martin. Next question is, person would like to know how you export the NURBS to Alias.
Yeah, it's a good question, but it's quite a simple answer. You turn this polygons into the NURBs in Maya, and then save your data or export the data in a wire file type. And a wire file type you can open directly in Alias is a native format, so you don't need any special file to be able to open these NURBs in Alias.
Thank you, Martin. Our next question. In terms of the differences between Maya and Aliases, why is it required to export data to Alias for post-process or post-design?
Mm-hmm. Yeah, it depends on in which phase are you at the moment. If you are on the very beginning, I would say it makes more sense to create your concept in Maya till level of detail you consider as acceptable. As mentioned before, some kind of details are difficult to create, but I would say if you create a complete main shape with all character lines, maybe some openings for air intakes, that may be the point you decide to move the alias and model additional features there. But it depends on a workflow, it depends on a goal you have, and it depends on different circumstances.
Thank you. Our next question poses person enjoyed your presentation greatly, it says here. The question is, there are a lot of places to learn Maya, but do you know of any courses in Germany that focus on the car industry? This question comes from an Alias modeler.
Okay, we cooperate with one company here in Germany. The guys provide introduction courses about polygon modeling. So if you want, just send me an email and I can provide you with a contact. You can discuss it directly with the guys.
Thank you. Next question, Martin. Is there a way to evaluate the surface shape in Maya? Like, for example, the curvature cones or zebra matting, etc.?
Yeah, there are some ways how to do it, but you need to be aware about one big difference. You don't work on a surface, so you don't have any geometry behind. It's defined by the NURBS equation, whatever. So you can use, for example, zebra shading in a Maya just to simulate this stripes flow on your surface. It works pretty well. You can't use the curvature evaluation on a polygons. There are no curves at the end. There are only polygons. There are only mesh. But there are some ways how to evaluate, or to say it in a different way, there are some ways how to smooth and optimize the geometry in Maya to be closer to the quality you can achieve with the surfaces.
Thank you, Martin. We have a couple of other questions. Question comes in that can Maya create a Class A surface, or is required to use Alias?
So I would say use the Alias. Alias is a tool. It's developed for a Class A surfacing quality, and in Maya you can work with the NURBS, but far from the level as Alias do. So my recommendation is, if you need Class A, go to Alias.
Thanks, Martin. Another question here. What about the importing of CATIA or Alias files to work in Maya?
As Maya is using direct connect translating methods or translator, you can import directly CATIA files. V5, about the V4 I need to check, but there are some translators for V4 as well. So you can use the native CATIA data even directly in a Maya or in some kind of references. But the answer is yes, you can use the CATIA data.
Okay, we've got a question here about where the zebra shading is in Maya. Is it possible for you to demonstrate that?
You need to do it. So it's not available by default, but there's a simple workflow. Create environment ball and apply some kind of zebra texture on this, and use it in a shader color channel, and after this it looks like a zebra shader in an Alias. So it's not available by default.
Thank you. one of our final questions now. Why didn't Autodesk plan to put Polygon Modeling into Alias?
Yeah, I can forward this question to our product management. That's something I can't answer so direct. I would say it makes sense for some workflows, but there is not only decision criteria about integration of this technology. So yeah, we'll see what's happened in the future.
Thanks, Martin. Another question here. How fast can you react on changes during the concept development process using Maya?
That's a nice question. So as I presented you my model shape I created, it may happen that in a real process the design manager or engineering order is coming in and you need to move one edge, one character line 10 millimeters down or 2 millimeters, very small changes. If you're working with the NURBS, you know what kind of effort is behind to open the geometry or a model, close it at or transition and deliver the proper curvature flow. In Maya, it's this change question of minutes, and from my experience, it may happen that you are able to discuss the changes with designer before the noon, and afternoon you can deliver him the changed model. So it's a really significant time saving in a process using this polygon modeling methods.
A question here, how long have you been working with this method, Martin? Are there any schools or colleges teaching students to work using this method?
I can't answer, unfortunately. I don't know about any university or college teaching Maya modeling. There may be a question of on the media entertainment division in Autodesk because they are acting more frequently with this category. Please try to check Autodesk webpage to check by the education about some courses or colleges providing this kind of teaching.
Okay, Martin, thanks for that. Going back to part of your presentation, how much time is needed to create the model that you've presented today?
Well, to create only a model is a question about 1 or 2 days, I would say. For me it was more because I need to bring some structure in a demo just to have some flow, but only the model it's finished in 1 or 2 days. I'm talking about working days, not 24 hours. No?
Thanks, Martin. We've got one final question for you here. This may have been touched on a little earlier, but I'll ask it anyway. What is the best way to bring a Maya model into Alias?
Yeah, I mean, I already answered something like this, but just to repeat it, you can save your Maya files directly into the wire file type, so native file type for Alias, and open it directly in Alias Automotive or Surface or whatever. So it's no neutral or specific file type needed to move it from Maya to Alias. Save it as a wire, open it in Alias.
Well, thanks very much, Martin. That was the last of the questions. We've had a lot of comments from the attendees saying how much they've enjoyed your presentation today. A lot of interest, obviously, as we can see from the questions. So that concludes our presentation today. Thank you very much for joining us today. Please remember that this webinar will be uploaded into our archives and is available to anyone who wishes to view it. You can access this and all previous webinars under the Process tab on the Car Design News homepage. Thanks again, and please don't forget to join us on October 24th for the last in this current car design series from Autodesk. This will be focusing on visualization. And thank you very much to Martin and Emil. Thank you very much.
Thank you as well. It was a pleasure to do this.